Okay, so for this lesson, we're going to take a look at the next form of linear relations, which is called general form. In lesson 2, we use the form y is equal to mx plus b to determine the equation of a line when given the slope of a line in the y-intercept. A linear equation written in the form y is equal to mx plus b has a slope of m and a y-intercept of b. Now, for general form, we call it ax plus by plus c, and you can see that we use all capital letters to differentiate from that lowercase b for the y-intercept. The general form of the equation of a line is an equation where all the terms are collected to the left side of the equation, so it all balances out to equaling 0. The general form is written as ax plus by plus c, where a, b, and c are expressed as integers, and a is usually positive. We're going to make it a rule for ourselves that a is always going to be positive in these cases. So we always want the coefficient of x squared to wind up being a positive number. The general form of the equation of a line allows us to write equations for oblique lines, horizontal lines, and vertical lines. In some texts, the form ax plus by plus c is referred to as standard form. So if ever you come across standard form, it's referring to the same thing as our general form. So the first thing we need to do is convert the following equations from slope y-intercept to general form, where a, b, and c are all going to be integers. And remember that we want the a value to be positive. So for the x's, we always want this one to be a positive. The b and the c can be positive or negative. So the first thing that we're going to do is we're going to check and say, well, is x positive? If x is positive, then what I do is I move everything to the right-hand side over to where x is. In order to do that, I'm going to subtract y from both sides, which means that I can state that 0 is equal to 5x minus y minus 8, or I can just put it in the other order. 5x minus y minus 8 is equal to 0. If they're equivalent, I can swap which side of the equation or equal sign that they're on. In the second case, x is positive, so I want everything to move towards the x. So I'm going to subtract y from both sides again. And I'm going to say that in this case, 2 over 3x minus y plus 7 is equal to 0. Well, now everything's positive, but I have this fraction in here, which can't exist. So in order to get rid of the fraction, I need to multiply every single term by 3 to get rid of that denominator. So if I multiply the first one, 3 times 2 is going to be 6, divided by 3, I have 2x's. Minus y times 3 is going to be negative 3y, and 7 times 3 is going to be 21, and there's my answer. For the last example, I can see that x is negative, so I'm actually going to move everything to the left-hand side in this case so that I can make x positive. So I'm actually on both sides going to add 1 over 4x and subtract 3 over 5. And I'm going to wind up with everything on the left-hand side where it's going to be 1 over 4x plus y minus 3 over 5 is equal to 0. And in this case, because I have two different fractions, I have a 1 over 4 and negative 3 over 5, I need to multiply by the lowest common denominator. Well, the common denominator between 4 and 5 is 20, so I'm going to multiply everything by 20. And I'm going to state, well, 20 times 1 over 4 would be 20 over 4, or 5x, plus 20y, and 20 times negative 3 is going to be negative 60, divided by 5 is going to wind up being negative 12. And there's my general form for this equation. If I'm determining the slope and y-intercept form from my general form, then all I'm really trying to do is isolate y. In every single case, I just need to get y by itself with no coefficient in order to make this work. So if I'm in my general form, the first thing I'm going to do is I'm going to move anything that is not y to the other side of the equation. So I'm going to subtract 2x from both sides, and I'm going to subtract 25 from both sides. And state that negative 5y is equal to negative 2x minus 25. And then I divide by the coefficient of y. So divide by negative 5, divide by negative 5, and divide by negative 5. And y is going to be by itself. Y is equal to, well, negative 2 over negative 5 is going to become positive 2 over 5. The negatives will cancel out. And negative 25 divided by negative 5 is going to give me positive 5. And there's my slope-intercept form. The same thing is going to hold true for b. First thing I'm going to do is I'm going to move that 6x over by subtracting 6x from both sides, move that negative 15 over by adding 15 to both sides. And I can say that 2y is equal to negative 6x plus 15. And I'm going to divide everything by the coefficient of y, divide it all by 2. So in this case, I can say y is equal to negative 2, or 6 over 2 is going to become negative 3x, and 15 over 2, I'm just going to leave it as 15 over 2. For example 3, the lines 3x minus 4y plus 8 is equal to 0, and 5x minus ky minus 6 have the same y-intercept. Determine the value of k. Well, all I'm going to state in this case is I need to figure out where the y-intercept would come from. I'm going to solve the y-intercept on the first one that I know and say that when I move the 3x and the 8 over, negative 4y is equal to negative 3x minus 8. Divide everything by negative 4, and y is equal to positive 3 over 4x plus 2. That means that, in this case, they both have a y-intercept of 2. When I go to my second equation, I'm going to say that negative ky is going to equal negative 5x plus 6. Or y is equal to 5 over kx, and then 6 divided by negative k is going to be minus 6 over k. And there's my y-intercept for the second case. If they have the same y-intercept, then that means that if I have negative 6 over k, it has to equal positive 2. Which means that when I multiply k to both sides, negative 6 is equal to 2k, or divide both sides by 2, negative 3 is equal to k. And there's my answer.